Okay. Hi, everyone. Thank you for coming to see my presentation. I'm Nikos Triantafillis, and I'm with Apstra. And in this presentation, we're going to talk about a little bit how we've integrated SONiC in our intent-based architecture. So all this time, lately, a couple of years now, you'll be hearing about intent-based data center automation. So what exactly is intent-based? To put it simply, intent is all about the what, not the how. Until now, we've been doing single box. We'll be going in our data centers or in your data centers from box to box, configuring devices one by one. Ideally, this is not something that scales. Ideally, you want a system that has the ability to capture what it is that you want your network to do, not the how. And you want that system to execute on the what and translate that what into the how, and give you the ability to go through your data center lifecycle, which is design your network or your pods, build them, deploy them, and operate them. And at the same time, define your underlay, for example, the types of links that you use to interconnect your pods and your devices, the routing protocols that you use to communicate in your data center, any virtual networks, VLANs, VXLANs, security zones in terms of VRFs, policies, and so on. You also want that system to help you with day-to-day operations. Just the design is not enough, right? And after you have designed and deployed your network, you want that, the whole idea about intent is you specify the what, but you want that what to be continuously validated, right? You want to make sure that my connectivity between endpoints is still there, but I still have my ECMP paths, my routes end-to-end and so on, right? And also you want, along with the real-time validation, you want your system to monitor your data center and warn you about anomalies, warn you about config deviations, do real-time correlation of events so that it can more cleverly identify root causes for you rather than just giving you a large pool of alerts. For example, cable is cut. You start seeing events or alerts about interfaces, about BGP, and if you expand the blast radius, you start seeing anomalies about routes missing or the ECMP number of paths not being the ones that you expect, right? And you want to have the ability to do all this using any type of hardware, right, that you think is suitable, whether it is OCP specification hardware, whether it's Cisco, Arista, and so on. And moving forward, you also don't want to be constrained and have a single vendor lockdown, not only on the hardware, but also on the software. So you want to have the ability to choose for many OSs. And in this case, since the SONiC community is, the last couple of years has really taken SONiC to another level and has taken it to the point where it can actually be considered now as a valid choice for intent-based data center automation, right? And to run clearly to a variety of switches that we have integrated into the SONiC repo. At the same time, that system, you wanted to have the ability to run different type of workloads, containers, and not only on premises, but also in the cloud, whether it is Azure or AWS. So under the hood, how does that look like? What does that architecture look like that you can actually allow you to achieve such an intent-based data center? Well, if we look at it from a top-down perspective, you want something that helps you interact with that system, right? It can be a UI, or it can be well-defined and documented APIs. And those are your entry points as a user to help you design, build, deploy, operate, and troubleshoot your network, right? So basically, those are your means of taking you through the whole development life cycle of your data center, right? And they help you build, they help you use some building blocks. We're going to look at it a little bit later to construct the model of your data center, deploy that model, and identify what devices you want to associate with that model. All this intent, this translation, the telemetry, the resources, whether it is hardware resources, software resources, pools, ACE number allocations, and everything needs to reside somewhere. And you also need a representation of your network in some form. So you need a single source of truth that captures all that. And in this case, in our network architecture, we use in our intent-based architecture, we use a graph data store to be the single source of truth and literally the sink and container of all this information. But again, this is only day 0, day 1 operations. Day 2 operations is all about monitoring and operating your network. So I believe you need something like a networking engine that comprises of intent-based analytics as well as root cause identification pieces that continuously monitor through telemetry, whether it is off-box or on-box telemetry, in-band telemetry, your network, continuously validate that intent, identify, report symptoms, analyze those symptoms, and alert you for certain events that you specify, as well as doing automated root cause identification. We talked about a little bit about the life cycle earlier and how you do that. You do that through the UI or certain APIs, and we said that the intent-based data center is all about the what. So we need to have an abstraction of the different components in your data center that is not tied down to, oh, I have a Cisco device, or I have a EdgeCore device, or I have an Arista device, but you really want to abstract this and design your network in terms of logical devices. You do that, so we have the ability to create that abstraction for you where you specify through logical devices your leaves, your spines, your superspines, as well as the requirements regarding their connectivity. What sort of speed or oversubscription do you want, northbound or southbound? And we use those logical devices kind of like building blocks, Lego pieces, which you put together, and you are putting together things like rack types. You're all familiar with the rack types, which basically is the grouping of the servers plus the top of rack switches, 1 or 2 depending on your availability requirements, and you're putting them together in this abstracted design. So the logical devices and the rack types you can then use to construct a template, which is basically how you want your data center to look like, right? And that template is once you instantiate it, right? It will produce a blueprint. The blueprint is literally how your data center looks like, and is instantiated along with these virtual networks, the security zones, its analytics, its root cause identification. While we are going to deploy that blueprint, you need some more information that come into this, right? At some point in time, you need to have the mapping between the abstracted elements in your blueprint, the logical device and everything, to the physical devices, right? And the architecture has the ability to, once you've also provided your physical device profiles along with their hardware and software capabilities, the port transformation or port breakout capabilities, to put together and bind based on whether those physical devices satisfy the requirement that you specified in your logical devices, and they band together the logical and the physical in your blueprint. And also you need to fit in other things like resource allocation, as I said, IP pools, ASN numbers, and so on. So designing your data center, I mean, we all know here that that is not enough. The most difficult part is operating it and analyzing and collecting data, analyzing failures. And the best way to do this is to constantly validate your intent in a continuous closed loop validation. And what does that mean? It means that once you've specified your architecture and you're monitoring, you've deployed that architecture and you're monitoring using your intent-based analytics. You provide that visibility to the user. The user may make operational changes, and again, that fits into the, those changes are feed back into the architecture, and that again is validated regarding, through telemetry, regarding reachability, regarding device health, and so on. The next step in an intent-based data center is root cause identification. If you want your intent-based data center to be not only the ability to specify the what, but also to self-remediate itself, or self-healing is another term that is being used. In terms of failures, root cause identification is the intermediate step. Let's take one example where you have, for example, in a leaf spine topology, you have somebody calling you, an application owner, calling you up and say, hey, you know what, I'm really seeing increased latency in my application, right? How do you identify the root cause for this, right? So you want that system to have, through intent-based analytics, the ability to process, or dynamically, first of all, deploy extensible telemetry and give you back into your closed loop feedback for analysis information to help you determine what is the root cause for that congestion, right? If you think about that, and that's a little bit difficult to do, because if you think about the congestion is something that may not manifest itself physically as an anomaly. It may not manifest itself in terms of output interface drops or input interface drops, right? It can be just increased packet latency end-to-end. So how do you actually capture that? And how do you actually do the root cause identification for that? So that's, so to have the ability to identify the root cause for your packet latency, for congestion, and also remediate that is one of the most important pieces and the next step in an intent-based data center. Of course, there are other cases where somebody could swap a cable, right? And you could start seeing routing anomalies or reachability issues. Clearly, in cases like this, when it's a physical issue, you know, the network won't remediate by itself. Somebody has to intervene and swap the cables back. But still, the same principle applies, that the information needs to be collected so that you can correctly identify the root cause. Some of the changes that we had to make in order to enable and integrate SONiC, which we announced a couple months back in our intent-based architecture and solution, we implemented a SONiC on-box system agent. If you remember a couple of slides earlier, we talked about how we talked about the whole data center lifecycle, right? You design, deploy, operate, and monitor. The on-box system agent that we've developed is responsible for pushing your intent, of course, translated through configuration, to the device. Right? And we all know that the configuration in SONiC is, in config.db.json, so it's responsible for taking the intent and pushing that in the configuration file for SONiC. At the same time, we also wanted to unlock certain capabilities of the routing application for intent-based networking. We have the ability, for example, to deploy SONiC as a EVPN node and control plane to exchange the VPN routes. To do that, we have to move forward in the routing stack. So we moved FRR from 4.0 to 6.02, right? And because we're lagging a little bit behind the community implementing certain features, and that's normal. We had to split the capability of configuring the routing application from SONiC. So if you're familiar with it, with how SONiC is configured, all the configuration resides config.db.json along with the routing application. So we made a split there so that we can take advantage of the extra capabilities that the routing application is offering to us. And that on-box system agent also has the ability to monitor any config deviation in SONiC. So if somebody goes on the box and makes an incremental change or makes a routing application change, it continuously monitors the configuration. And it also has it's also responsible for retrieving on-box telemetry and shipping them off to the graph data store that you saw earlier. Right? And for security purposes, we also put the management interface in a verb. So these were the minimum steps that allowed us to integrate SONiC in our intent-based networking solution. So we talked about, let's see. So we talked about having the ability using iOS to deploy, operate SONiC, as well as root cause identification. And I wanted to show you, I want to go through a couple of slides that basically showcase what exactly we have achieved. And you can also see a live demo for root cause identification in our booth here. We put together a network, and physically the network is a typical leaf spine topology using Quanta Trident 3 switches, all of them running SONiC. We attached traffic generators on the leaf on the left, in the middle node, which is the spine, and for collecting back the traffic on the leaf to the right. The idea behind this is the physical topology is we wanted AOS to use SONiC and deploy the topology, design the topology, deploy the topology, operate the topology, and also collect data, inbound telemetry data to root cause identify congestion when the traffic generator pushes traffic through the system. We have a steady flow running at 95% line rate from the traffic generator to the leaf device here. And we generate a bursty flow, just enough of traffic so that we don't see output interface drops on the spine. The congestion will happen at the egress point of the middle switch. And the idea is that through Broadcom's IFA, we have the ability to collect the IFA provisioned data through in-band telemetry that is sent to an AOS collector from the egress SONiC device. The data is analyzed for any anomalies, right? And then we communicate that data back to the AOS server. So here you see the device facts from the Leaf 1 device. You can see, and this is typically how you would also expect. I cannot see what. Yes, so we can see here the device facts for each of the device running SONiC. What is the device itself? Some other information regarding the OS, the version, which AOS server it's communicating to, management IP, and so on. And this is how the AOS Manas blueprint looks like. That is actually running SONiC on all devices. And we see that everything here is nice and green. We check the deployment status. Everything is reporting fine. No anomalies. We monitor layer 3 connectivity, routing, liveness, the fabric, BGP routes, LLDP, ARP, and so on. And here we actually looking into the intent-based analytic part of AOS, where we have deployed an IBA probe that is capable of doing microburst detection, right? So in this case, you can imagine that the scenario is somebody's calling you up and says, hey, I'm seeing latency between these two endpoints. So through the IBA probe, we've gone and configured the flow that is of interest to us with the source and destination IP. And these are the devices that we've configured IFA for. So basically, the devices will call, when the flow matches the configured flow, it will attach metadata to the packet as it traverses those configured nodes, and then eventually they will be sent back to the collector. So here we see that once we start the bursty flow, we have the user has configured a kind of threshold that he wants to be alerted, after which the congestion occurs. So for example, if I set my threshold to be, let's say, 2 milliseconds, and if that threshold is exceeded, I want to be alerted. And through the collection of data, when the bursty flow is enabled from the traffic generator, we see that on spine 1, we have detected congestion in the form of this bump, which is actually representing as well the duration at which point we stayed above the threshold that we specified. And we also have data as to, how much the duration, how much was the congestion duration. So you can see how very, very quickly what our intent-based architecture looks like, how we integrated SONiC into this. And we believe that SONiC is a viable option for intent-based networking. The community has done a very good job in feature velocity, in stability, and the result of that is that there is a growing interest by outside of the community, by enterprises, by data center operators to look into SONiC and with Apstra's AOS, and they're considering it as a viable option for cloud campus and data center environments. So the call here is, We want to encourage the effort in the SONiC community to intensify and focus on certain key areas like the stability, feature velocity, manageability, which I saw a couple of the presentations are already trying to address, and telemetry. And if you want to see any of those demos live, please come and see us at our booth, and I'll be happy to show them to you. Any questions?
Yeah, great talk, Nikos. Thank you. Quick question on the AOS agent for SONiC. If you are not running AOS agent on box, it means that you are running it on the server, correct?
Right. So we have two solutions on this. We have the ability to run on-box or off-box agents. There are certain scenarios or certain environments where they don't allow us to deploy the agent on the box.
So if you are running it on the server, do you have one agent for each box? How is it basically done from this scale point of view?
It can be, yes. It can be.
It's just one agent per box on the server. So you basically, if it is controlling 100 switches, you have 100 agents running on a server, is it? Yeah? Okay.
Yes.
Okay. How does it scale? I mean, have you really thought about doing something different?
Well, the agents are not necessarily, they're not heavyweight. They're lightweight components that are purely for communication to the box, right? The heavy lifting is done by the server, by the AOS server, right? So they're there only to just push configuration, monitor the device, collect telemetry, and on-box telemetry, and that's not too much of an overhead. But you can definitely see how, how does it actually scale? What needs to scale here is not necessarily the agents themselves, but the back end that talks to the agent, right? Because it needs to arbitrate and collect information from potentially thousands of servers. So right now we have the ability to scale this to thousands of devices.
So there is something else behind the server?
Yes. Oh, sorry. No. So the off-box agents are separate entities from the AOS server.
Okay. So server is the one which is collating, which is essentially is building the graph and so forth, right?
Correct. Okay.
So is it just a single server, or is it potentially a cluster of servers?
So
as a logical,
as scalability grows, we actually have started looking into how we can deploy a cluster of those servers.
Okay. All right. Thank you.
Okay. No more questions. Let's thank Nikos.